Welcome to another episode of Travel Geologist, where we share the beauty of landscapes, specifically the geology that is inherent to these landscapes. For this episode, the focus is on Brae Head in Clarendon, Jamaica. For those of you who are unfamiliar with Brae Head is located centrally in Jamaica. As you can see in this Google map as reference, the red highlights indicate the specific locations of Brae Head. Now, Brae Head, in terms of its location from a geologic point of view, is situated within the Rio Minho Crawl River Fault Zone, considered as one of the most seismically active fault zones in Jamaica. What piqued my interest in these maps is the highlight of shifted rivers as well as bisected hilly terrain. It's also a case that this landscape or this area, Brae Head that is situated relatively near to Pennants. And if you guys would have been following up on some of my videos, you would have come across the Pennants gold mine video. Now, with this being said, how did I end up at this location? Well, I was invited by a friend, Nikki, to participate in this group's hike. The name of this group is the Jamaica Hash House Harriers, a very good hiking group. So when I first entered into this area, and upon doing a pan of the area, this specific location grabbed my interest first. And this location, I could see that there is at least two major faults intersecting. And that flat location in the center, that grabbing, is as a result of that interaction of the two. So that first was what caught my eye. Second is where you can see I am actually here looking at what appears to be sand to gravel size rather, volcanics immersed in a clay matrix. So that basically indicates to me already that this environment is a volcanic environment. So after the briefing, the hiking began. And as we trekked the route, I then turned my eyes to the flanks. And this outcrop is what I saw. You can see rounded class, big boulders, and this is an indicator of a volcaniclastic bedrock structure. These boulders, as is highlighted, indicate that they came from a higher source and they would have rolled down the hill and stopped right there. What it is that I can see from this representation here is that in terms of the volcanic class, they are relatively pink compared to another source of volcanic rock. Now, this flank is a highlight of an area that is weathered and as well degraded. This line here grabs my attention, this lineation. You should see that there is a degree of oxidization of that clay layer, and you can also see that the tree roots follow the degree of lineation within this weathered strata. So the key thing here is that I can see that there's a degree of mineralization, I can see that there's a degree of weathering, there's a degree of erosion. And these volcanic clasts are badly weathered. So that rock fall that I would have seen a while ago is highly likely given the highly weathered nature of these rocks. Continuing the journey of the hike, and we can see that definitely the nature of this landscape is such as well that, agriculture is well supported. I mean, if clay is the final derivative of the erosion, then obviously it will make for great agriculture. As we continue on this trail, we came across this relatively large fixed location. It's brought to my attention by one of the community representatives that this location is for entertainment purposes. You can see that where this location is situated is where the waterfall as well as the tributary flows, and you can see that the banks of the tributary is being eroded, which indicates that in times of flood this location can be further eroded. Specifically here as well, what grabbed my attention were these black sands. If you would have seen some other videos of mine, you would see where I indicate that black sands are located in other locations in Clarendon. Where this specific spot is, Brae Head, it is more so closer towards the source of the river, which basically means that the entirety of the river, and even so to a wider extent the entirety of Clarendon, especially where this inlier is rich in black sands. And if it's rich in black sands, then it's also likely to be rich in other key minerals such as copper and even gold. This waterfall is definitely a beauty. Brae Head Waterfalls. You can see from the big boulders that it's a very powerful waterfall in flood time. Continuing down the trail, you can come across this representation of prior construction work to rehabilitate and stabilize the road. Where the water flows is where there's a natural break in that structure. This is naturally where the water will flow as a result of a fault zone. So it is likely that in terms of road damage, it's going to be a regular occurrence. Here, taking another pan, can see that the hilly landscape has a relative split as a result of that faulted tectonic slash active earthquake zone. Do you notice that flat layer in between the two hills? So that can also be interpreted as a graben. That's where the river also flows from. Here we see bamboo, and where there is bamboo, that's an indication or indicator of clay. These bamboo, as you can see, relatively green, which indicates that they are being well fed in the context of moist areas. From that specific spot, I ended up at this higher location of the river. When I ended up here, I was particularly interested in the reality of these very black spots. When it's a case I see the water on it, and when I scratch the area, I see that these spots are highlights of black rocks. You can see me here touching a couple of them, and essentially the water is the erosive force. So these rocks, once it's a case that they become eroded, we will tend to then have the black sands be a product of that erosion, and hence at the lower levels of the river there is deposition. Where this river flows, we continued along that trend, and we eventually ended up at the waterfall. But before I visited the waterfall, I just continued to trot along as far as I could, just consistently looking at what it is that I'm seeing in the rocks. I could see the cavity layers. I could see obviously that where the water flows is where there is a degree of black or mafic rocks. What I was driven to conclude is that these rocks are different than those that I came across earlier in this video. Remember those pinkish rocks? Compare them to what these rocks look like, and you will see that this is not the same. This represents a difference or a change in the volcanic nature of these rocks. Whilst they may both be what we call andesitic, the fact that these rocks here have more black to them indicates that there is a difference in the magma setting. So that is something that is very beautiful to recognize from this. Of course, we had to have a look at deep into the water. So these are just a few of the captures. After our visit to this final waterfall, we made our way to end the trail. Now before I show you the videos slash images ahead, pay attention to this map, specifically the linear expressions. These linear expressions represent the chief fault or earthquake scarps that make up this zone, the Rio Minho Crawl River Fault Zone, that is. Northeast, southwest, east to west, north to south. These are the three premier directions or trend of this fault zone that I can identify here. I also can identify locations that have anticline, syncline, folded strata. What I was not expecting to see is a cavity or a depression slash sinkhole in or on top of a hilly location. So let's go into this spot. So as we continued the trek and we ended up on the top of the hill itself or the landscape itself, you can see now we come across the pine trees. As we moved through, what I am paying close attention to is what is the nature of the landscape setup. What is very, very good to see is that, these trees are being relatively maintained. But in between these trees, we can see that there is a degree of flat zone. And then I came across this area where you can see this relatively depressed area of water. Looking at these agricultural crops, yams to be specific, as well as sweet potatoes, and looking at the soil type, you can see it is silty clay. What this says to me is that in terms of drainage, it's not going to be relatively fast for this water to drain. But how could this water spot be here? That was a question that raised in my head. As I observed the landscape in a 360 pan, I could see that one of the answers to that is the way how the landscape is aligned. You can see the higher layers above and that structure, that depression in the center. As I continued my trek, I could see that there is a degree of a pattern in terms of how these trees align. They align themselves in a way that is in keeping with what we call the fault trace. That for me is where the map is actually represented in the field. So using this compass here, I was basically looking at the trend and I could verify that this is not only the spot where water will flow, it is also the representation of the fault trace. This fault trace, as we continued down this hill, we could come across seeing those areas where it is relatively susceptible to landslides. I could also see those layers of black sands, and even continue along the trail, I could see that then, the alignment shifts somewhat into a north-south. This water will flow, which eventually goes down to the Brae Head Falls. It's flowing in a north-south orientation. This now also grabbed my attention. Clay, orange brown, and it is looking somewhat different than the pink zones around it. How is this possible? When I looked closer, I could see that to a degree, there is a degree of this mineralization in some of the weathered class within the rocks themselves. Could it be that it is an alteration as a result of chemical weathering? Possibly. Could it also be that there's a degree of mineralization, that's represented by the iron oxidization, and even potentially, copper-based oxidization potentially as well? That is going to require some additional testing. But as I continued my journey to the end of the trail, nonetheless, you know, this is just me highlighting that where we were walking is along the trace of a given fault zone. These rocks, you notice the pink hue again, volcanic clastics, all of this in terms of how the rocks are rounded indicate that these were formed as a result of water action, which suggests that these rocks could have been formed within the sea. Here it is, we're at the end of this trail. And as newbies in this group, it's a case where, as is their tradition, we're given a little mugshot, and it was a good experience overall. So hats tip off to this group. But as you can gather, there is a lot that is to behold in this Brae region. And even with all that I would have highlighted here, there is still so much that I was still unable to share. Some of those you will see in the shorts version of this video or in the short clips related to this video, and others you may come across it in future videos. But this is just a revelation that there is so much to behold in our world. Until the next episode, Travel Geologist, over and out.